Alright, time for another draftphysics.com, debatephysics.com also. Double slit video, it's been a while. So, another one of the very important subjects where physics got it all wrong. They jumped to the wave conclusion way too soon. Very simple pattern, on-off, simplest pattern the universe can make. And yet they state with some kind of confidence that, well, all physicists are well trained to know every time there's an on-off pattern, it must be interference. That kind of nonsense. Anyway, so, yeah, like I said, I haven't done it in a while. There probably are better videos. Maybe I'll link to the last one I made. I think it's the last one I made. Goes into probably more detail than this will, but, it's, yeah, it's got all the details in it. Is that dark enough? Yes, it's dark enough. Okay, they always draw it this way, all right? So they just, this young kind of drawing, and it's incredibly superficial, simplistic, and entirely inaccurate. Just right on its face. They already start off way wrong. All right, so, to make their waves. All right, so that's probably enough of it to get the idea. And the idea is that what will happen is there'll be these vectors that will create interference, destructive and constructive, in the sense the lines double. And in water waves, what it means is the water vibrates up and down, and then there's a place where there's no vibration, where it doesn't go up, it doesn't go down, it just stops because the two cancel. And then the waves are very active again, and then there's a place where they cancel. So it does happen in water. But the key feature, the obvious feature, is right here. Okay, this idea that a photon goes through the slit, no matter where it goes through, and somehow we are to randomize it to one location, and the one location, just looking at it visually, here's the center of the wave. These should be the 2 points of interest, that is, the 2 places you would put your math to figure out your vector. So if you're doing water waves, these is where you'll draw your vector lines from, would be the 2 centers of the wave. That's where the action's going to be. That's where the 2 lines will be decided about how much distance they travel and how in phase or out of phase they'll be. And so the real giveaway is physicists never use those locations. Okay. And the real truth is, again, is they do something, they have this catch, like the slits have to be infinitesimally small. So really narrow slits, and you could understand if you already understood it as an optical experiment, that is, that whatever's causing the effect, it's optical, it's photons, that those would be essentially point sources. They would be places from which vectors can be drawn. And the very fact is that, if I put 2 headlights really close to each other, 2 light bulbs, and then from like 10 feet you can't tell there's 2 light bulbs. So the closer they're together, they essentially become one vector, and there's only that one vector. So because the slit surfaces are so close to each other, essentially they turn the double slit pattern into the single slit pattern. And then they can talk, trash about how it functions because they're looking at the wrong pattern. And I've been over this before. So the simple truth is, it's a surface experiment. So when they say single slit, what they're really saying is it's the 2 surface experiment. This will be the distance in the math. This is where you'll draw your vectors from, is the corners of the slit. That's where it'll be decided whether it's in phase or out of phase. And that's pretty obvious. And the fact is that I can make a single impediment experiment, and exactly the same rules will apply. Now, what I won't have is this bright center because I have an impediment in the way. So I'm going to get some shadow, okay, from the impediment. So the center won't be as bright. Obviously, more light is in the center here than in the center here. Okay, all right. But clearly, the wave theory breaks down entirely with a single impediment, right? Why would you expect I mean, both patterns, like I said, the patterns are very, very similar. I could just say the only difference is how bright the center is in one of them. So that would be about it. But it can make hundreds of bars, literally, okay? Or it can make, you know, 2, just depending on how far they're apart. So that's the other thing that's kind of obvious. The further apart they are, the bigger the distance in their math. That means they're just saying a bigger base in the triangle, and more wavelengths fit in that bigger distance. It just means there's more places where there's going to be a change from on to off, on to off, on to off. And so the bigger the distance, the more bars, the smaller the bars, and the smaller the distance, the bigger the on-off nodes are going to be. So there's a simple truth. They never tell you that stuff. They never make it clear that's exactly how it functions. It's really just a matter of saying how far apart are the two surfaces. That's all they're measuring, is how far apart the two surfaces are. So the math is saying one thing. The image is saying something different. Now, they don't draw the single slit. So they have no explanation for how a single slit creates interference. So the truth is they can't draw it, because if they draw it, where are they going to put the waves? They have to put 2 waves. They have to have 2 vectors. Now, obviously, the math says the wave is here and the wave is here. The wave center right on the surface. So obviously they're not going to draw that, because, well, then they have to explain, well, how did the wave overlap the surface, and how's the center there? Doesn't make any sense. Why would the 2 waves be created? What caused the waves to split right here in the middle? So they can't draw it because, yeah, they can't explain it. So it's a completely broken, there's no continuity in this explanation at all, that 2 lumpy waves come out of one slit. It doesn't happen in water. It clearly is a nonsense. Okay. So, but you won't see an image of that in any of the video icons. All right. So we have the catch of the infinitesimally small slits. The catch of the single impediment creating the same exact pattern, no slit. Okay. The no slit experiment. The 2 surface experiments, okay, they're both 2 surface experiments, and the real double slit experiment is really the 4 surface experiment. So that's all it's really about, is that you're creating 4 surfaces by combining 2 single slits. All right, and you can really think of it as combining, 2 separate single slit experiments, with this little catch that you can move these in this direction. And you really literally are, except the way they think about it. They're not realizing that what's really fundamentally changing is now you have 4 surfaces, not just 2 surfaces, and you're going to end up with 2 surfaces that are very far apart and 2 surfaces that are relatively close to each other. Either these 2 surfaces or the single impediment going to be close to each other. So you have 2 patterns. You have an envelope pattern that contains another pattern with little dots in it, the bars. The big distance is going to tell you exactly how many bars you're going to have going around. And again, it should be done from an equidistant from the experiment. The target should be a round surface, so you get the right intensity and the right proportions to the pattern. Because it's supposed to be, their math has an L distance, and L distance is supposed to be the same distance, and obviously a flat surface doesn't create the same distances. All right. Obviously. All right, so one of the big mistakes they make, this one Feynman does, everybody's done it. All right, that stupid Brian Greene guy does it, they all do it. They all say, most famously, I suppose, Professor Lewin, because he uses this line that it's non-negotiable. Okay, so you have a single slit, and let's say the photons are coming in this way, all right, through the slits. And they're going to, what's going to really happen is you just have 4 point sources, is the simple explanation. The photons are going to be interrupted on the surfaces, broken, and then you're just going to cast them like a wave center. You're going to scatter them. So that's essentially, scatter in all directions will look like a wave front. It's not a wave of any kind. None of the scatter is connected to each other. But the fact is, it'll have the same shape, okay, in terms of a time dependency. How far away the little bit of stuff will go in an amount of time will be the same as a wave front, okay. So what they do is they say something, so your target's over here. So your pattern is going to be cast very far from your source. And the theory is that somehow the light is going to spread like on a movie projector. Movie projectors have a lens, okay? They spread for a reason. There's no lens here. So it's not about spreading what's going through these 2 slits. So they'll always say something like, well, what if you threw baseballs through the 2 slits? You'd just end up with a clump here and a clump here. And they pretend like on the target you'd end up with these 2 things very far apart. This whole experiment is a millimeter, okay? So it's very tiny. The whole experiment's right every day, a little tiny bit of space. When you cast it on the wall, you're going to get a pattern of bars, okay, that's going to be maybe a foot across. So you're starting at a millimeter, and you're going to have a pattern that's a foot across. You're not, the millimeter doesn't care anything about any idea of spreading. It's not the 2 openings in the slits don't do this. That's got to be caused by the interference with the surface. That's got to be caused by scattering the light. So the spreading has to be caused by a surface. So the light going through the 2 slits is actually just going to be a millimeter apart. So in this 1 foot of distance, it's 1 millimeter, where light from this side would be, the same as light, where they're both converging. So this is only inside of 1 millimeter. Any light converging, where you'd say, oh, look, it's an equidistant because they're converging like a perfect triangle. Look at that, they're converging. No, that's inside of 1 millimeter. The real pattern is created by light going from this surface and this surface and this surface and this surface. Those are the real lines going in the same direction, or what's creating the fringe pattern. Photons from the surfaces on that side of the experiment go that way, and surfaces on this side of the experiment go that way. And obviously they go all ways. But those are the ones that matter. The ones going in the same direction are the ones that are going to decide the pattern. And this is really easily understood if you just, all this is just, none of it's taught honestly. It's just a gigantic fabrication. Probably best to use a single slit, but we use the double for this example. So let's say I was going to figure on these 2 lines. These are the ones that are going to decide. So I'm scattering at each one of these surfaces, creating vectors going out to this, where I'm broadcasting it. All right, and a simple way to understand it is to say, well, this is a surface and this is a surface, so let's make those lines. And the difference in those lines is going to decide what this is going to be here. Right, so there's 0 degrees, let's call that. At 0 degrees, well, it's dangerous. We could use that as 0 and then 90 left and right. Well, it's always going to be, you have to go 180 degrees. But anyway, so this is just going to tell you the exact length difference. And if it's, an even 18 wavelengths, then it's going to be an on. And if it's 18.5, okay, then that's an off. So the full integer rule will tell you whether this is an on or off, and you can figure out that depending on what this is going to decide what all the rest of this is. And so the sender isn't guaranteed to be an on at all. Now the explanation is pretty simple, that all of these things are going to be creating those nodes, but there is a millimeter of distance between these different surfaces, and the fact is they're essentially creating patterns that begin at those distances. So the two patterns are out of sync with each other by that little bit of distance. And what you're really doing is when you create the nodes, the center, okay, is really two nodes overlapping because of that difference between the two surfaces. So that little bit of difference is enough difference to force two nodes to be created, and essentially, that are a little bit off the same center, and essentially that's your double maxima. So physics won't give you any explanation for why this center is twice the size. And the obvious answer, in my opinion, is that, well, yeah, your surfaces are in two different places. One surface is creating one pattern, the other surface is essentially creating the other pattern, and they just happen to overlap in the center. And so perfectly reasonable explanation. All right, the pattern does, the nodes actually do, because of the geometry, they actually get smaller as you go towards the center. All right, what they've never done, okay, is simply put photographic capacity. They could even put a full multiplier, even just a diode that is light sensitive, just to see if any light, going through the slits, ends up going to these locations. These, that the pattern actually is 180 degrees. Because if it was a wave pattern, it should be. The intensity here should be the same as the intensity here, as the intensity here, as the intensity here if it was a wave. And the fact is you can just look at the patterns and you'll know that, oh no, it fades out. It gets weaker and weaker and weaker as I go this way, and it shouldn't be. Now, obviously, casting on a flat surface gives you that illusion anyway because of the distance, but we know that that's that's the inverse square law, and so it's going to fade because you're sending these photons going here are going a longer distance than the photons going here, so obviously they're going to be weaker, smaller amount. But that's really not what's causing it to fade. What's causing it to fade is the fact that what's really happening is the surface has electrons on it, and they're on the surface, okay? And the photons, okay, are little bits of energy. They're hitting the electron. The electron's moving in and out, okay? That's the vibration, the heat, okay, common to all things, and it's vibrating. So it's probably a good idea to call it heat. Now, what we haven't seen is that this double slit experiment done with super cold objects, because it would be a little bit interesting to see if there's very little electron motion, whether anything happens at all. But anyway, the electrons are moving in and out on the surface. You can sort of understand. Always, constantly, the energy imbalance is always existing. They're always doing some jittering. So but they're either moving out of the surface or back into the surface. And so when the photon comes through, it has its vector. It hits the electron, and the combined vector is a new vector. That's going to be the scatter, okay? And the energy is really in the fact that the photon's going to be pushing into a field of energy that is around all of us. Right now, what you're seeing here, colors and light, is the fact that energy has come in, and it's reflecting off of me based on how much pressure little electrons on my surface are providing, and that's deciding whether you see orange or yellow or black. What color you see is completely being decided by that function. The electrons are deciding what color you're going to see. All right. And so the simple truth is all that's happening is the photon, which is a combination of little bits of energy, one of them gets deflected, and the rest fly through, and then on the other slit, the other surface, one of them gets deflected that way, and they're all getting deflected constantly. There's the ones going by the surface are being hit into electrons. They're pushing the electron into the field, pushing it, and the field, okay, gets that that pressure, the pushing out pressure, and so all you're doing is saying, well, can I hit the surface with the same pattern? So I break the pattern that's going in. The pattern going in goes in. It's broken by the surfaces, but all the surfaces are throwing the pieces at the wall, and they're throwing them all in the same plane because the electrons are just moving in and out. They're not doing this, and they're not doing this. They're doing this. So the whole fringe pattern ends up on the same plane because that's where the pieces are being sent. And it's just a 50-50 argument where they're in phase or out of phase, and it clearly just has to do with the distance from the surfaces. And so you have a 50-50 chance that when you throw a bit, it'll either be in phase or out of phase in terms of the amount of frequency it has. So let's see if I'll take a pause and see, there's so many giveaways, but it's really just an argument about point sources. As soon as I create the two surfaces, the photons do interact with the surface, so only the surface photons, the ones that go by the surface, they're the only ones creating all the fringe light. And let's understand, in the classic experiment, 93% of the light goes straight through and hits the surface. It's only the 7% that creates the fringe pattern. All right. So, yeah, it's probably enough. I'll see if I can think of anything else that I've left out. Just for emphasis. So there are two distinctly different patterns. The two surface experiments, that is the impediment and the single slit, produce a pattern very similar to this. It could be, like I said, 60, 70 of these going out, depending on how wide a slit you create and how much light you're using. And then the double slit has this distinctive pattern. So the patterns really aren't very similar at all. And the only way you get this pattern using the double slit is if you obey that infinitesimally small slit stuff. So if you make a slit that's actually opened more than a couple of wavelengths of distance, you're going to get the more complex pattern. And the more complex pattern doesn't have the double maxima in the sense that it's a little short. Okay, there'll be 5 dots, then there'll be 3 here. So you can always multiply this times 2 and subtract 1, and you'll know how many are in the center. So 3 plus 3 is 6, so minus 1, 5, that kind of thing. So it obeys very strict rules, and just by knowing the opening size of the slits, you can know everything you need to know, in the sense you know exactly how many nodes would be created over the 90 degrees. So you just multiply that by 2 and you have your answer. But that's what's deciding how many little bars there are, is the fact of how much distance there is between the surfaces. That ends up creating only a certain number of triangles that can possibly create an in-phase and out-of-phase pattern. So it's about in-phase and out-of-phase, not constructive and destructive. And that's where they've ruined physics, is they think phase is only a wave function, that you can't throw baseballs that have a phase. Where two people are throwing baseballs at the same time, at the same frequency, that is the same, just as often as each other, at the same exact time. Then you would argue that the two streams of baseballs are in phase, and then if one was throwing exactly when the other guy halfway between his phase, then they'd be half phase out of phase, and the baseballs would hit a surface not at the same time. You wouldn't call that a wave function. You wouldn't say that has to be a wave. It's baseballs. There's nothing to do with waves. Okay, so it's not a wave phenomenon anyway. It is made out of baseballs, bits, photons, quantum of energy. And their whole theory that they've based this on, creating entanglement and superposition and all kinds of wacky crap about, things being obliged to travel magical random paths and all of that, is all wrong. It's a very mechanical system, and that's all it is a system. You're putting an obstacle in front of the photons, you're messing with them, and it has consequences. And the consequences are easily dissected as just routine physical phenomenon, the routine physical phenomenon of scatter. So, maybe that's enough. Let's see. All right, finishing up. So if you imagine the surfaces, okay, as places where something is being scattered, and that stuff being scattered, baseballs or whatever, have to hit a location at the same time. Okay, so they're coming through, they're being scattered at those point sources like they were light being projected. And the simple truth is you can understand the phase argument. They're going to hit at the different times depending on what distance I'm shooting them at, because of that Pythagorean triangle thing. Okay, so in some locations they're going to hit in phase, in some locations they're not going to hit in phase because of the different path lengths of the distance they're traveling. And where the baseballs hit at the same time, that's an on. Where they don't hit at the same time, that's an off, on, off, on, off. The geometry works perfect. So it's perfectly explainable with a particle theory. So their big lie that no particle explanation can explain is just that. Again, the fact that they keep talking about two photons coming from the middle converge, the on has to be in the center. And again, that's happening inside of 1 millimeter. So out of the foot of light, you're going to say this little millimeter here decided everything, when no, it didn't. Okay. And all of the fringe light, all the light going out, is all photons that travel near the surface. And the gigantically bright center proves that point, that the fringes are made out of a small percentage of the light that goes by the surface. And you can also understand that the smaller I make an aperture, the more likely a photon is going to be near a surface. So that's also part of it. Obviously, this also applies to interferometers and other mechanisms where you create a round fringe pattern. Same exact thing. The double slit is just doing it in one plane, where a round aperture does it in every plane. And that's why you have a round fringe pattern. Alright, so that's probably enough. But yeah, everything they say is exaggeration, distortion. It's all just a manipulation. Again, them saying infinitesimally small slits for the double slit, when all that does is turn a double slit pattern, this more complex pattern, into this simple pattern. Because essentially, you've eliminated two of the point sources. So you can understand that if I make the slits really small, these 2 points are so close to each other, the vector is going to be the same. No matter where I draw the line from, it's going to be in phase, out of phase, in phase, out of phase. And if I have some distance between those vectors, then it makes a difference. Now there'll be two distinct point sources, where if they're close together, they're not distinct, and you've turned a double slit into a single slit, because two of the point sources are so close to each other. So you can do the same thing by having slits, but then have a very narrow impediment, and you have a similar situation where two of the sources have now been essentially turned into one source. So then you only have like the 3-source experiment. So I guess I should include that you're going to get a distinctly different pattern when you have 3 sources. Alright, so that's probably enough now. So, till the next time and such. But this is a key experiment in the history of physics, and they didn't do any of it with any care or detail or scrutiny. They just jumped to the wacky conclusion and went with it. Decided it's nail in the coffin evidence, light has to be a wave. And this is in the context of all the other experiments kind of demonstrating light can't be a wave, like the ultraviolet catastrophe, the photoelectric effect, black body radiation. So you have all this other evidence indicating something completely different. And they forced this to carry the ball, so to speak, for the wave theory. And the only way they could do it is to contrive all these gimmicks. Talk about round waves going through slits, draw round waves where the wave centers aren't the math they're using. So their own math is telling them they're drawing it wrong, and they didn't even pay attention to that. And you trust these people. They can't explain a simple two-slit experiment honestly, and you trust them. My simple argument is you're making a big mistake.